Nowadays, the image sensors are everywhere to perceive various scenarios, covering from security surveillance to medical imaging. And because of that, image sensors are combining with data-driven computer vision model, which means constructing a machine learning model from a large amount of visual data. To construct a data-driven computer vision system, people conventionally split the sensing and the processing by implementing them on standalone image sensor and digital processor respectively. However, such system suffers from high energy consumption and high latency because of intensive image acquisition and intensive off-sensor transmission. The fundamental reason of the sensor's inefficiency is the sensor assumes the end consumer is human, so the sensor is designed to generate high-quality images. With a high-quality image, the off-sensor processor can well execute the task. However, the processor might still execute the task with good performance, even though it receives a low-dimensional image that the human cannot even recognize. By doing so, the intensity of image acquisition and off-sensor transmission is relieved while the downstream task performance is maintained. To make sure the low-dimensional image keeps all the key information that the task requires, a joint optimization between the sensor and the downstream task should be set up. In this way, we construct a new image sensor design paradigm, machine-centric vision pipeline. Following the design idea, we propose LeCA, Learned Compressive Acquisition. By learning, it means inside the sensor, we use an encoder to map image to its low-dimensional representation, and at the processor end, we use a decoder to convert it back to the image. The encoder and decoder are co-trained offline with the downstream task, so that the low-dimensional representation contains a task-specific information. By compression, it means the low-dimensional representation removes redundancy in the raw image. By acquisition, it means the encoder is implemented when the image is just captured and is still in the analog domain. The performance of LeCA is superior. It achieves up to 6 times compression with less than 1% accuracy loss on ImageNet, and it is compatible with digital compression. It consumes more than 6 times lower energy than conventional imagers and more than 2 times lower energy than compressive imagers. For more information about LeCA, please join us on Wednesday.